Hello everyone and welcome to my talk about going serverless on Azure. My name is Culjak and over time I've transitioned from being a .NET freelancer to being a cloud solution architect. For the last approximately 2.5 years I've been building various cloud solutions which were leveraging serverless either completely or partially. And during that time, I've had an opportunity and a privilege to, misuse serverless and find out what's not working. But that's basically the price of being an early adopter. So what are we going to use today are Azure Kubernetes Service and the virtual kubelet, which is basically hosted on Azure Container Instances. We're going to go through Azure Functions and their durable functions. We're going to cover Service Bus, queues and topics, Event Grid, Azure Monitor, API management, and at the end, the old logic apps. And yeah, I think it would be really boring to just talk about them and list all the things they can and can't use. So let's build a system. Here's an imaginary problem. There's a news agency which is getting a whole bunch of photos and videos submitted, and they actually have people to categorize them by hand. So what do we have at our disposal? Let's imagine that there's a third-party service that returns a JSON describing the content of a photo or a video sent to it. Well, actually we don't really need to imagine it. There's Azure's cognitive services which do exactly that thing. We have a webhook which we need to call once we're done with processing, and we have the whole Azure at our disposal. So let's start with a diagram and place a webhook that we need to call and that imaginary third-party service. So what's the fastest thing to do to solve the problem that we have at our hand? The fastest thing to do actually is to have the web app to which the user uploads some photos and videos call that third-party service. But here's the problem. It's long enough for a human to wait for the payload to be uploaded. It would take even more time to wait until the service processes all that data, and that's in a case if the service works, but that there might be an outage or the service might be timing out, so the whole process of uploading the news could break. Another thing we could do is develop a monolith and host it on a platform as a service. On Azure, that would be Azure's App Service. That's fine if you like monoliths, but here's the problem. When you need to scale, it takes time. It's not instantaneously. It will take a minute or two. And it's scalable up to a point. For example, you can scale to 10 virtual machines. You can't scale to 1,000. There's another problem. Keeping an instance of app service costs money. And the biggest problem perhaps might be that if we want to develop a resilient service, we need to implement event sourcing or some other way to handle outages or crashes of our service. For example, when someone sends us the data and our service crashes, we don't want to bother the user to upload the data again. We just want to continue where we've stopped. So what are we going to do today is design a mostly serverless system around the service that categorizes photos and videos. On the input side, we're going to receive an HTTP post request which will send us a webhook URL and multiple photos and videos. What we are going to return is a 202 and a request ID. That request ID will allow the caller to join the request it sent to the response it will get on a webhook. but also at a later date we might be able to implement another endpoint which will allow the caller to ask our system what's the status of the process. On the output side, we'll basically call the webhook and send a JSON. So let's start. The first step is to have something which will respond to HTTP requests. That something needs to handle the HTTP request as soon as possible without too much delay, upload all the data to Azure storage, respond, and before responding with a 202 accepted, pass the process request down the line. So, before we go any further, please remember, serverless aren't functions as a service. Although, when we talk about serverless, we mostly think about functions or on AWS lambdas, but that's not serverless entirely. Functions are mostly hosted on serverless, but serverless is much larger. When we talk about serverless, we basically talk about not caring about the infrastructure, because in theory, we get all the infrastructure we need when we need, and we pay only for the part when we are using it. So, the best thing we can place here are Azure Kubernetes Service combined with virtual kubelets. So the cool thing here is that Azure Kubernetes Service is the regular Kubernetes, only the master node, the thing that orchestrates the whole service, is hosted and handled and upgraded and cared about by Azure. So you don't actually need to worry about it. And Azure Kubernetes Service usually use a number of virtual machines, and you can scale them from 1 to whatever. What virtual kubelet gives you are serverless containers from Azure container instances. The beauty of that combination is that when your Kubernetes service gets too much requests for the virtual machine, which is online already to handle, it will burst out to serverless infrastructure. And that's cool because it will take much less time to get an additional core or a number of additional cores from the Azure container instances than it will take to spin up a new virtual machine and deploy your container on it. So this hybrid combination works wonders. And another cool thing is that you can actually watch over your Kubernetes service, and once it starts bursting out to virtual kubelets, you can start spinning up new virtual machines. The reason for doing it is that you might anticipate some peak loads, and paying for a virtual machine per second or per hour is cheaper than paying for a serverless container. Okay, what you can do in Kubernetes is host a container, and that container can host a normal API which you already have, or you can even host functions. So containers on Kubernetes are actually the easiest way for you to leverage or lift and shift your existing code and place it in Azure onto something that's serverless, because the only thing basically you need to do is back it up. There are some limitations compared to self-hosted Kubernetes. For example, you can only use a single size of virtual machines to scale out. You can't combine small virtual machines with bigger ones. For that, you need to spin up another Kubernetes service, but all in all, it's a great solution. So let's add Kubernetes service and blob storage to our diagram. The next thing we need to do is, once the process requests go down the line, we need something that will get them, read them, figure out what do they need to do. For example, figure out, do they need to call a photo service or a video service, or call them multiple times, and then they need to do it in a loop or in parallel. Once everything is done, they need to form a response and send it down the line to the webhook. Okay, so here are some problems that we might have. We need it to be stable. So once the process starts, even if it fails, we need to be able to continue. It needs to handle crashes. For example, if we send a photo to that third-party service and for some reason it crashes, we need to be able to retry it. In case of an outage, for example, the whole Azure data center goes out of power or disconnects from the internet, we need it to be able to continue. And this is a problem for functions. It needs to last as long as needed. So if the whole processing takes 2 days, it needs to be able to wait for 2 days. First of all, let's talk about Azure Functions. We've probably all heard about them, but you probably aren't aware where can you host them. The serverless way is actually the consumption plan, meaning that you pay only for what you use and you get some instances on which you can run your code when needed. The Azure App Service is another way you can host your functions, meaning that you basically rent a virtual machine. And when scaling out, you just add more and more virtual machines. But that scaling out takes time, it takes a few minutes. A third way to host it is on a machine you own, be it your on-prem machine, your on-prem virtual machine, or a virtual machine in Azure, AWS, Google Cloud Engine, or wherever. So how can you host it there? There's a cool thing called Azure Functions Runtime, which allows you to run your functions somewhere where you install it. And the reason for using it is when you need functions to respond immediately, but also be able to scale out. In those situations, you would have some sort of a load balancer in front of them, and then send a few requests to your virtual machine and a few to the consumption plan once it spins up. Another reason for using Azure Functions Runtime is if you have CPU intensive work, meaning that the instances, the virtual machines, which are basically V1s, VMs from Azure, if they are too slow for you, you might need something that's faster, and you might rent a really fast virtual machine on Azure. For that reason, Functions runtimes are really cool. And now there's a premium tier, which is still in private preview, which basically allows you to do what Azure Kubernetes Service plus virtual kubelets allow you to do. You will be able to rent a certain amount of cores and RAM to be constantly online, and then when more work comes, you will just rent more and more instances like in the consumption plan. The benefit of the premium tier is that you won't have any cold starts, and your tasks won't be limited to 10 minutes. Okay, so how do all of those scale? We've mentioned that app services scale slowly and to a certain amount of machines. Based on which plan are you using? Are you using a basic, a standard, or a premium one? When you're running all of that on your machines, it will probably scale slower than app services, because it means that you need to scale more machines on your side, be it virtual machines or actually buy and place new hardware machines. Premium tier, as mentioned, is similar to AKS, and it should work splendidly. So let's focus on the consumption plan. The process can last up to 10 minutes. After that, your process is being terminated. You can scale up to 200 instances per function app. And remember, a function app can have multiple functions in it. And you can scale up by one instance at most every 10 seconds. So those are the problems. Another one is your instance will go to sleep after 20 minutes of inactivity. And now here come the hacks. You can preheat them and you can keep them alive. How? If you know that the instance is going to sleep after 20 minutes, all you need to do is add some work within less than 20 minutes since the last process. That will keep it alive. If you want to preheat and spin up multiple instances, you can send multiple workloads. And when you have functions, you can set a key which determines how many concurrent requests can be processed on a single instance. So if you set it to 1 and send 10 requests in parallel, you will spin up multiple instances, and then all you need to do is keep them alive. So, how are we gonna implement this? There's a thing called Durable Tasks framework, and the implementation on Azure Functions is Durable Functions. That's something that we really need for this. They enable us to run long-running functions while maintaining local state. So although functions are stateless, durable functions allow us to have state by using event sourcing. So whatever happens, whichever step goes on, it's being logged onto an Azure storage queue. So that allows us to remember what we did, which then allows us to easily chain our functions or fan them out and in, to handle external events, to sleep and wait for something, etc. The cute thing is that we can call a function from another function directly by just saying, hey, call that function, instead of sending a message to a queue and so on. So let's go further. It's not magic, it's the Durable Task framework. So here's an example of function chaining without durable functions. What you would do to call function 2 from function 1, function 3 from function 2, function 4 from function 3 is send a message to a queue. Why? You might call the function 2 directly from function 1, but you have a problem of 10 minutes expiration, and you will be charged for both of them. So chaining is kind of a problem, although a solvable one. By using durable functions, what you can do is just have a single code base which says call function, call another function, call the third one, call the fourth one. You can place it in a try-catch block and see if something failed. In the previous example, you couldn't see if something failed without having even more functions taking care of it. Another problem is fan in. So fanning something out isn't really a problem. You just send a zillion of requests, but getting them combined together is a problem. By using durable functions, all you need to do is spin up a number of tasks and then call task when all, and your code will await for all of them to finish. So let's add durable functions to our diagram. Next step is we actually need something that will be alive for as long as the third-party service is processing. And that something needs to be as cheap as possible, but also quickly scalable. So functions aren't really a thing for this. What is a solution here is yet another Kubernetes service and a virtual kubelet. Why? Because it can keep running forever, and there's nothing really important here for us to catch if it crashes, because the code in durable functions actually worries about if something has crashed. So the only thing this needs to do is get the request, call the third-party service, and send the response back. So let's add another AKS to our diagram. Okay, cool. The step number 4 is actually getting the data back to durable services. And this is actually a pretty neat thing. There's something called external events on durable functions, which allows you to generate a URL that you need to call when there's an external event that happened. In this example, we are creating 2 tasks. One is a timeout task, and the other one is the external event task. And we await for the first one. If there was a timeout, we'll escalate. If the data has been processed, meaning that an external event happened, we will continue. What this allows us is to send a message down the queue to the second AKS and put the durable functions to sleep. When the second AKS receives a response from the third-party service, it will ping the durable functions back using the URL, and everything will continue. So let's place that callback here. Okay, so cool. But we've left out something. Our parts aren't really connected. First of all, let's mention the difference between events and messages. Events are basically information which we send out, and we don't really care what will happen after it. For example, imagine a wife or a mom cooking a dinner, and when it's done, she can say the dinner is ready. And she doesn't really care what happens after that. Message, on the other part, is kind of a command. In that case, she would go to each member of the family and say, hey, go to the table and eat some dinner. That's the difference. So instead of going to multiple members of the family and saying, go to the table, which would be an equivalent of sending a bunch of messages down the queue, which are the same, there's something on Azure that's called Service Bus Topics, which allows us to send a single message to the queue, to a topic actually, which then gets multicasted to as many subscribers as they are. Okay, so the first AKS will send messages to topics. We don't really need them right now, but it gives us a place to extend our service. For example, we might add the billing service as a listener, or an analytics service as a listener, and so on. Another thing which we'll add here is event grid. So event grid will be listening to topics, and then when there's a new message in the topic, it will ping and start durable functions. Why? Because durable functions can't listen to topics. So we need something that will call the HTTP URL. And when the durable functions will be triggered, they will fetch a message from the topic. At the end, we'll add a queue between the durable functions and the second AKS. Why? So we will be sending messages to that queue about which photo or video needs to be processed. And that message will also contain the external event URL the AKS needs to call. In this way, we have a decoupled system which can scale its parts independently, and the only thing we actually really need to be stable and reliable are the durable functions. Okay, so when something crashes, there's a cool thing now called Azure Monitor, which actually listens to the whole cloud, collects all the logs, and you can send more logs there by using the Application Insights SDK. But what we've built doesn't have any security. And there are three ways we can handle that. We can handle it in a normal API by leveraging some capabilities of your framework of choice or by using some libraries, etc. So basically the standard thing you would do. If we went with functions on the front-end side, meaning that we host the functions in AKS, well, we would have a fun time. Why? Because what we get in functions is the raw HTTP request message, meaning that we would be left to ourselves to handle, well, everything. Or we can perhaps find a cool library. The third solution is using Azure API Management. It's an enterprise-grade service, but it recently has gone serverless, meaning that instead of having to pay $200 per month per region, you can now pay for it per usage. And the beauty of it is that you can create various subscriptions and throttle the parallel calls, meaning that you can create an entry-level subscription that you charge, for example, $50 per month, and then a premium one which you charge $500 per month because you give them unlimited parallel calls. So let's place the API management at the front end. Okay, so I've told you that we're gonna talk about logic apps, but how do they fit here? Usually they don't, but the news agency is an old news agency and they are getting a huge portion of news submissions through emails. And the easiest thing we can actually do is use the logic apps, which are basically if this then that on steroids, have them watch our mail inbox, and whenever there's a mail which meets some criteria, ping our newly built system. Okay, what happens when we want to extend the system and we want to extend the API? There are two solutions. One is Azure Functions proxies, which are they're great. They are basic, but they are a cool tool. Proxies allow you to, well, basically mock an API, hard code a JSON response, rewrite the request or the response and relay it to another API. Just be warned, while you're calling another API, you are being billed for that waiting time. On the other hand, API management has all of that and even more. It's a really powerful solution, but since up until recently it was extremely pricey, it wasn't something for a hobby project, but now it is, so look it up. And that's basically it. Thank you for listening, and ping me if you'll need me. Thank you so much.